Engineering YouTube channel. So today we are going to discuss one of the interesting subject that is a control system. Okay, so as of you know that a control system is widely used in mechanical engineering or in electrical engineering. So in electrical engineering it is used to see the stability of any control loops or in any electrical circuit. Okay, so in control system, as you know that there are different analysis, like time domain analysis is present, frequency domain analysis is present. So before moving towards this complexity, first I will introduce you some basic concepts of a control system. That basic concepts are nothing but your open loop control system and closed loop system basic understanding, and also I will discuss the singularities function. Okay, and some theoretical or MCQ type numericals on that one. Okay, so before moving towards this open loop and closed loop system, first I will give one example of practical example of system. That is for this I choose water tank as my practical example. So first we'll see the what is a components are included in that practical example. This is my practical system. This is a water tank system. Okay, so this is the input valve for this water tank, and this is the output valve for a water tank. And what we are doing, supposedly I am designer, I want to maintain a flow from this water tank. Okay, continuous flow. So for that, what I am designing, so I want to maintain 100-meter heights. Okay, in this water tank, this is your H height. Okay, so for that, what I am doing, I first I set my desired value, that in this case it is 100-meter, and what I am doing, I am measuring instantaneous value with this water bob. Okay, so this water bob measuring instantaneous value, and it is giving input to your control part. Okay, it may be controller or processor like this, and relative error is find out between these two values, and proportional signal is generated, and it is feeding towards control element. In this case, control element is nothing but your water valve. Okay, so now I am going to explain the block diagram for this practical system. So we'll see the respective block diagram for this system. So as I explained, we are finding error between your measured value and your set value. Okay, so that error is nothing but this this error. Okay, E. So and this is your control signal. Okay, so it means that control signal, your control signal P is a function of your error. Okay, this is f of s. This is a variant, and this is a variable. Okay, so your control signal is totally depends on your error signal, right? So now we'll move towards our respective block diagram for this system. So as we discussed practical example of water tank, so for that example, this is block diagram representation, right? This one. So this is the input for this system. Okay, this is the input valve representation, and this is the output valve representation. Okay, so what we are doing, we are measuring the current water level with the help of a water valve, and we are comparing this set value and your measured value, and you are producing or you are generating error for your controller. And controller means your P controller, I controller, PI controller, controlling your means working on your error signal and producing proportional output function. Okay, means output signal. So your output signal, as I told, output signal is a function of your error. So this is a basic understanding for water tank example. So now we'll move towards, means we'll see the closed loop diagram for control system. Means this closed loop system basically used for means used to design any control system, right? So this is a general block diagram representation for a control system. Okay, so this is your plant transfer function, this is your feedback gain, this is your output, this is your input R of S. So Now I will describe, or I will evaluate how this g of s divided by 1 plus g of s h of s will come. Okay, so now you have to focus on this e, right? This error is nothing but difference between r of s and b of s, these two signals. Okay, so we are doing subtraction, means r of s minus b of s, right? Because negative, we are giving negative feedback signal, means there are different types, means there are two types of signals are available. First one is a negative signal, which is shown in this diagram, and another one is a positive feedback system, right? So basically these two signals have their different advantages and disadvantages, but as compared to this signal with the same platform, then definitely you are able to say, or you are able to predict that a negative feedback system will more stable as compared to your positive feedback system. Okay, so for example, we are considering negative feedback system. So this c of s is nothing but your output. Okay, so as you know that transfer function is nothing but uh, d- dividation of your numerator divided by denominator. Okay, so numerator means your output signal, okay, in c plane, and your denominator is nothing but your input signal in s plane, right? So for these two, means if you are finding out a transfer function for any system, then definitely you have to calculate that transfer function in s plane only. So output divided by input, and most important statement is that you have to consider all initial conditions equal to 0. So if you are following this condition, then you are able to find out a transfer function. Basically, to find out transfer function, we are using state space analysis. Means if I want to find out a transfer function of any drive or any electrical network, then definitely I am able to find out with the help of state space analysis. So we'll move towards the description of this closed loop control system, right? So as I explained, the description of control system means u of s is equal to r of s minus b of s. So hope all of you are now understanding what is a u of s, right? So now what we are doing, we are replacing this b of s using c of s h of s. Why we are replacing b of s using c of s h of s is that, just consider this is your feedback element. Okay, means feedback gain h, and input for this feedback element is nothing but your output signal, that is a c of s, and output for this feedback system is nothing but your b of s, right? So as I told you, transfer function is nothing but the ratio of your output signal divided by input signal. So in this case, output signal is your b of s and input signal is c of s, and transfer function is h of s. So what you are doing, b of s divided by c of s is equal to h of s, right? So now I want to replace this b of s. So what I am doing, I am sending out this c of s to right hand side. So b of s is equal to c of s into h of s. So now what I am doing, similarly I am transferring this g of s to right hand side. So c of s is equal to r of s into g of s minus c of s h of s into g of s. Okay, this g of s I am multiplying, right? So now what we are doing, we are transferring this minus c of s, g of s, h of s towards the left hand side. Okay, so after transferring this minus c of s, g of s, h of s, right, total this part. Okay, so what we are doing, we are taking c of s as a common, and remaining part now we are transferring to again right hand side. So it come at a denominator. Okay, that is nothing but 1 plus g of s, h of s, right? So but as I told you, transfer function is nothing but your ratio of your output divided by input. So in this case, what is your output, c of s, and what is your input, r of s. So I have to take the ratio of this c of s divided by r of s. So r of s is in this position. So now I am transferring this r of s towards left hand side. Okay, So this is your final equation for your closed loop control system. That is nothing but G of s divided by 1 plus G of s h of s. Okay, so now we'll move towards the another system, right? So now we'll focus on open loop system. Okay, as of now we have seen a closed loop system. So first we'll see the open loop system, some important points, and after that I will explain the block diagram for open loop system. So important point is that means whenever you are going to consider open loop system, then at that time definitely you have to consider the ideal system. Means if you are feeding any signal, means you are testing your open loop system, okay, and you are verifying the accuracy for that open loop system, then at that time definitely you have to consider the distortion free input signal. Okay, so this is the important point which I have mentioned as a third number point. Okay, so and another important point that this whatever I have told is that without disturbances. Okay, so if you are comparing your open loop system and closed loop system, then your open loop system means if you are considering or if you are verifying open loop system with a signal such signal don't have any disturbances, then definitely open loop system is much more accurate as compared to your closed loop system. And your closed loop system uh, and your closed loop system actually your open loop system is more stable as compared to your closed loop system, and your closed loop system is much more accurate than your open loop system, right? Understood. So now we'll move towards the block diagram of your open loop system. So I will define or I will elaborate each and every functionality of open loop system. So now we'll see the block diagram of open loop system. So before moving towards the block diagram of open loop system, first I will give some introduction or some information about a practical example which we have seen in our closed loop system representation, that is your water tank example system. So what is the difference between these two examples? So I will elaborate that one. So in open loop system, what we are doing, we are not feeding your measured value, that is instantaneous value, to your processor. Okay, in this case I saw that we are measuring this uh, output signal. Okay, but I am not feeding this output signal to my processor part. Okay, right, this is a major difference. Okay, these two system have a difference in this point. So I am just displaying that my output value, right? So this you have to understand. So now we'll move towards block diagram representation for open loop system, right? So this is open loop block diagram representation. This is your transfer means gain parameter for your system, and this is a feedback parameter. Actually we are not giving this feedback to means for comparison. Okay, this is isolated from this section, means it is not connected to this summing point. So this is a simple block diagram representation for open loop system, that is R of s is the input and C of s is output, and open loop system does not have any feedback parameter. Okay, so as of now we have seen just a basic of open loop system and closed loop system. So now we'll discuss one network analysis. Okay, so in this network what I have done, I am supplying this network with voltage V, and in this network so elements are resistor and your inductor. So you can say it as either it is a stator winding of DC motor or armature winding of DC motor. Okay, so as I told you, transfer function is nothing but a difference of your output and your input signal. Okay, so what I am doing, first basic is that all elements are transferred to S plane, okay, instead of T plane. So this R in T plane represented as R in S plane, and this L inductor is represented in T plane, and in S plane it is represented by SL. So in further lecture I will describe about why it is expressed as a SL. Okay, so first now what I am doing, I am applying Kirchoff's voltage law for this simple equation. So what I am doing, so V of S is the input and I of S into R of S. Okay, and just I am applying KVL. So this is your voltage drop and then I of S into your L of S. So now I am taking I of S as output. So equation will be I of S into R plus SL. And now what I am doing, as I told you, output transfer function is nothing but your output divided by input. So if V of S is your input and I of S is your output, so I have to rearrange this total equation with respect to this output divided by input. Okay, so the I of S divided by V of S is nothing but your R1 divided by R plus SL. So what I am doing, just now I am taking L as a common, okay, from denominator side. So just I am rearranging these equations, right? So now we'll see the basic form of transfer function. Okay, so this is the basic form of your transfer function. Okay, that is a C of S divided by R of S is equal to K into S plus Z1 into S plus Z2 divided by 1 plus T1S into 1 plus T2S. Okay, so these are zeros of a transfer function and these are poles of a transfer function, and this is a gain function of your transfer function. Okay, so S plane S plane have two axes, that is, this is a real axis and this is your imaginary axis. As like that in our XY plane, this is the X plane and this is the Y plane. So in S plane, Y plane is represented by imaginary axis and your X plane is represented by your real axis. Okay, so now we'll see the significance of zeros and pole in a transfer function. So poles and zeros of a transfer function are such critical frequencies. So 0 is a such critical frequency. If you are putting that frequency value, then your transfer function value will become a 0, and pole is a such critical frequencies. If you are putting that pole value in your transfer function, then your transfer function value will become infinite. So these are significance of your pole and zero representation in transfer function. So now we'll see the singularities function in a control system. Okay, singularities function are nothing but your input signal. Okay, first is your step signal, ramp signal, parabolic signal, or your impulse signal. Okay, so one by one we'll see the singularities function. So first we'll consider step signal. So step signal have T domain representation, that is R of T is equal to A, U of T. A is nothing but your magnitude. In this case we are considering A as a 1, that's why what we are representing Q of T is equal to 1. 1 is your magnitude. I can say it 100 or 1000, whatever it may be. So greater than T is equal to 0, this is your T is equal to 0, it is it have certain magnitude, and less than T is equal to 0, it have 0 magnitude. Okay, and if you are taking Laplace transform of this function, okay, then it will be R of S is equal to A divided by S. So now we'll move towards the second singularity function, that is a ramp signal. So ramp signal T domain representation is equal to R of T is equal to A T. Okay, right, this is your magnitude. Okay, and similarly as like step signal, it is it have positive values greater than T is equal to 0, and it has 0 value as compared to less than T is equal to 0. So if you are converting this T domain to S domain, then it is represented as R of S is equal to A divided by S square. So basically while converting T plane to S plane, what we are doing, we are just simply taking a Laplace transform. So as of the basic form of Laplace transform, that is I will explain basic form of Laplace transform, that is a T to the power n. So T to the power n in this is in T domain. Okay, now I am converting to the S domain. So what I am doing, I am considering n factorial, okay, divided by S to the power n plus 1. Right, so now what is this, in this case t to the power 1. So this is a n is equal to 1, so 1 factorial divided by S to the power 1 plus 1 because n plus 1, so it is 2, and it is multiplying with your respective magnitude. In this case it is a, right? So now we'll move towards third singularity function. So third singularity function, in this case it is nothing but your parabolic signal. So parabolic parabolic function representation is nothing but r of t is equal to a t square by 2. Okay, so t square by 2, now I am going to convert this t plane to s plane. So t square by 2 is represented by 1 by s cube. Okay, so simply whatever I told for in case of this the ramp signal, that means t to the power n is equal to n factor divided by s to the power n plus 1. So in this case n is 2, so 1 by 2 into what, 2 factorial divided by s cube, right? So these 2 and these 2 get cancelled out, that's why 1 by s cube is just remaining, and we are multiplying that 1 by s cube with our magnitude, that is a. So now we'll move towards the last singularity function, that is nothing but your impulse signal. So impulse function is a last singularity function, right? So what I am so now just impulse function is represented by r of t is equal to 1 at only t is equal to 0, and for any values, means either it is t is equal to 1 or 0.1, it is considered as a 0. Okay, so if you are taking integration of this t is equal to 1, then it will be 1, because now what this is suppose you are finding out the area for this signal, then what area is your length divided by you multiply your height h. So a into a is get cancel out, so remaining is 1. So you are representing that one. So I will now I will explain the importance of this impulse function. So if you are feeding means if you are feeding any system, means control system, with an impulse function, then output of that system is nothing but representation of a transfer function. Okay, right? So I will see that one. So this is your transfer function. Okay, so c of s divided by r of s is equal to f of s. So now in this case r of s is your impulse function, that is nothing but your 1. Okay, right? So 1 into f of s is equal to c of s. So what it means, this r of s is 1. Okay, so it means that your output is a replicate of your transfer function, system transfer function, that is nothing but your f of s, right? So what you are doing, so what you are doing now, so now I will explain some relation between the singularities function. Okay, so if you are derivating this parabolic signal, then it will be ramp signal, and if you are integrating this ramp signal, then it will be parabolic signal. Similar case for your ramp signal. Okay, if you are derivating this ramp signal, then it will be step, and if you are integrating the step, then it will be ramp. Like step signal, if you are derivating the step signal, then it will be impulse, and if you are integrating this impulse signal, then it will be a step signal. So in next lecture we are going to see some important examples on this basic understanding or introduction part. Actually that examples are most important. Actually I will take different examples from ESC or gate like this. So please attend that lecture also, and if you have any doubt, then you can convey that doubt, or any clarification, then you can convey to our management system, right?